Hello everyone. Under the subject of protection of power system, today we will discuss some overview introductory part of induction motor protection. So there is a wide range of AC motors such as three-phase induction motors, three-phase synchronous motors, single-phase motors, commutator motor, etc. But above 90% of motors used in an industry are induction motors because they are cheap, robust and easy to maintain. For higher rating of motors, we prefer high voltage because it will reduce operating current and the size of the motor. So because we will use the high voltage for operating the higher rating of motor, so there are most chances of faults in induction motor, and it is very severe fault or major fault occurs in induction motor. So we need to protect the induction motor very sensitively. So now we move to their first slide, that is what we will cover in this lecture, that is why we require protection of motors, what is the causes of failures, what are the different types of faults, what are the different abnormal operating conditions occur in operating of induction motor, features of motor protection relay, that means what will be the features, yeah, what have the features of motor protection relay which we will use for protection of induction motor, and what is the different types of setting of different elements of the relay which is used in protection scheme of motors, and what are the different protection schemes we will use for protection of induction motor. So now we move to first, that why we require the protection of motors. To understand this, first we need to know the cost associated with the failure of motor, that is loss of production, that means cost of production. Next one is replacement of motor, that means when any major fault is occurred and we have not designed the protective scheme for this type of motor, then we need to replace the faulty motor. Due to this, the replacement cost will be high, and cost of repair, cost of main hours due to this emergency, that means in accordance to their cost, the if any failure or any abnormal condition or any major fault is occurred in induction motor, then there will be major loss, accounting as a cost associated with the failure of motor. So to reduce this type of loss, we need to require some basic protection schemes or some protection scheme for the different types of motors. So if different types of fault, then we have must the different types of protection scheme for different faults for motors. So in consideration of cost, we need to require protection of motor. So now next is what is the basic causes of failure of motor. So the causes is basically, for protection of motor we have to identify the various causes of failure and to address the same. The various causes of failure is like thermal stress on winding. Thermal stress on winding, that means if a motor runs continuously more than its rated capacity, then this will overheat the winding and insulation, and due to this the winding insulation resulting in failure of motor. If the voltage is less than the designed value, then also it will overheat the winding at rated load and failure of the motor can occur. So this is the one causes to thermal, if any thermal stress is occurred in winding due to when the voltage is high or when the voltage is below the rated. So due to this, the winding insulation will be maybe fail. So next cause is single phasing. In case of single phasing, we can say that if loose of one phase supplied to motor, in case of three phase motor, leads to single phasing. If we start the motor on load, then the motor will fail due to imbalance. Next one is earth fault. If any part of winding comes in contact with the ground, then we can say the motor is earthed. If we start the motor in this condition, then it will lead to failure of motor. Next cause is short circuit. It is very obvious if there is a contact between two phases of a three phase winding or between the turns of a phase, and then this will be termed as short circuit. And we all know that during the short circuit the current is extremely high. So due to this high value of current, there is lead to failure of motors winding or motors. Next one is locked rotor. As the name mentioned here, locked, that means if the driven equipment is in jammed condition or the motor shaft is jammed, then this is known as locked rotor. If we start the motor under locked rotor condition, then it may causes the fail of the motor or some other types of fault is occur during the locked rotor operation of motor. Next one is number of hot start. Number of hot start, we can this explain as like each motor is designed to withstand a certain number of hot starts. Now consider a motor is in running condition. If we stop the rotor and immediately start the same, then this is called as a hot start. Depending upon the thermal curve of a motor, we have to give certain time to bring down the temperature of winding. If the temperature of winding is high, then there may be cause to heat up of winding or burning of winding, and due to this the failure of motor is occurs. Next one is bearing failure. If bearing fails, then the rubbing of rotor on starter will occur, resulting physical damage of insulation and winding. The bearing failure can be avoided by monitoring the bearing temperature. Bearing temperature detector is also used for monitoring and tripping of motor in case of abnormality. So these are the causes to initiate the failure of motor due to different types of fault or different types of conditions. Now next one is, what is the type of faults? So the type of fault is basically categorized as the stator faults and rotor faults. In stator fault, we will see in generator protection lecture, in previous lecture, there are same stator fault in generator, that is phase to phase faults, earth faults, interturn faults, and at the same time there is a rotor faults. Such faults are more likely to occur in wound rotor motors. Fault in wound rotors may be either earth faults or interturn fault. In stator fault, we can also show that basically faults in the motor windings occur chiefly due to insulation failure that may occur due to excessive temperature rise. Phase to phase faults are rare because enough insulation is provided between phase earth faults and more likely to occur. Interturn faults, under stator fault category there is a interturn fault. So interturn faults invariably develop into earth fault, so it is considered unnecessary to provide separate protection against interturn faults. In rotor turn fault, basically such faults are more likely to occur in wound rotor motors, and the fault is either earth fault we can also know, so that the conductor to earth faults, or interturn faults, which are caused by severe mechanical and thermal stresses. Other faults that are likely to occur include failure of bearings, and faults in starters and associated circuits are categorized as a rotor faults. So these are the basically type of faults which is occur in three-phase induction motor or synchronous motor, which we need to protect. So now next one is the abnormal operating condition. So the normal way, the abnormal operating condition that are likely to occur are, that is first, overloading. Overloading is caused by excessive mechanical loading, short time cycle overloading. It causes excessive temperature rise of windings and deterioration of insulation, resulting in winding fault. Hence, basically overload protection should be necessarily provided in electrical motors irrespective of the type and size of motor and the type of load which is being driven, and these factors, this type of abnormal condition is depend on this type of factors like size of motor, type of motor, and the type of load which is being driven. Now next abnormal operating condition is stalling. due to mechanical problem or overload at start motor may stall and may refuse to start. This is not desirable because in such a condition it draws excessive current. Hence, the immediate isolation of motor from supply mains is essential. Now next one is unbalanced supply voltage. We all know that the unbalanced three-phase supply causes negative sequence current to flow in the motor that is likely to cause overheating of the motor, or due to overheating of the motor, this is the causes for failure of winding. The next one is single phasing. As earlier I mentioned here, this is caused when one of the supply lines get disconnected, maybe due to any reason, such as blowing of a fuse or open circuit in one of the three supply connections. In such conditions, the motor continues to operate single phase provided that the load does not exceed 55 to 60% of the normal rating, with about the same temperature rise as when carrying rated load as a three-phase motor. Basically, single phasing may cause extreme magnetic unbalance, reduction in torque, and overheating due to negative phase sequence currents. This operation is not desired as it may cause damage to the motor, and therefore protection against single phases is necessary to provided. Now next one is under voltage. As name mentioned here, under voltage, and it clear that the under voltage supply will generally cause the motor to draw motor current for a given load. Hence this protection is also provided. Reverse phase, the name already meaning there explained the what is basically reverse phase. Basically the direction of rotation of a polyphase motor is reversed if the phase sequence is changed. In some motor applications, such a protection may become an essential feature of motor protection. Next one is loss of synchronism. A synchronous motor may pull out of step due to severe overload or due to reduction in supply voltage. So these are the abnormal operating condition where the motor operates. This type of abnormal operating condition, we need to provide a protection scheme for the motors. Now next one is features of motor protection relay. So when we will use the protective scheme or protective relay, so these are the features which have must present in the protection relay which is used for high voltage area. So first feature is thermal overload protection, short circuit protection, single phasing protection, earth fault protection, locked rotor protection, and number of start protection. These are the some features which must be present in our protection relay which is used for motor protection. So now next one is setting of different element. So we will use the different types of relay for different types of faults. For setting of the relay, we require the current transformers ratio and full load current of the motor. So the setting of different element is likely first thermal overload element. To set this element, we have to first identify the percentage of full load current on which the motor is running continuously. Next one is short circuit element. If we want to set the short circuit element, the range available for this element is approx 1 to 5 times of starting current. Time delay is also available, and basically we normally set it at 2 times of starting current with a time delay of 0.1 second. This is the approx value. Now next one is single phasing element. If we protect due to the abnormal operation due to single phasing, so when we will protect, the setting of single phase element will be, so this element will operate if there is unbalance in current of three phase. It is also called as unbalanced protection. The element is set of approx 1/3 of starting current, and if it tripped during starting, then the parameter will change to half of starting current or something like that. This is the only approximate value we will set in during the practical purpose. Now next one is earth fault protection. This element measures the neutral current of star connected current transformer secondary winding, and the range available for this type of element is 0.02 to 2 times of current transformer primary current. Time delay is also available for this type of protection. we normally set at 0.1 times of CT primary current with a time delay of 0.2 second. But if this type of relay trip during starting of motor, then we can change the time setting to 0.5 second. Number of hot start protection. Here we will provide the number of start allowed in specified time duration. By this we will limit the number of hot starts given to the motor. Now next one is locked rotor protection. For this type of protection scheme, we will change the range available for this element is 1 to 5 times of full load current. Time delay is also available for this type of setting of element. We normally set at 2 times of full load current. But if the motor, starting time of the motor means the time required by the motor to reach its full speed, and we will set this speed to the 2 times of full load current. So this is the basically different settings of different element I mentioned here. We need to provide this type of setting for better protection scheme for the induction motor. So now these are the listed some protection schemes we will use for induction motor protection. It is basically HRC fuse, overcurrent relays, differential protection scheme, earth fault relay, negative sequence voltage relays, under voltage relays, overload relays. So most of the protection scheme we will already study in generator protection, but the working principle of this protection scheme which we will earlier use in generator protection scheme is same, but we will discuss in further lectures one by one these types of protection schemes. So thank you very much, and I hope all of you enjoyed this basic overview of induction motor protection lecture. So thank you very much.